Hello everyone, I am Pushpita Chanda and I'm the TA for this course Introduction to Laser. I'm gonna discuss some additional things today. So first I want to convey some message that I have discussed few examples time to time in classes 3 week number 3 and after that please go through that and also the questions given the assignment that's are enough. The solution has also given and how to solve the question that is also given in the solution. And also whatever extra I have discussed that is from a book written by Sylvester and sometimes Boyd for nonlinear optics. And if you want to go through those things, and sometimes Ajay Ghatak optics, so you can go through those books and further strengthen your knowledge about those topics. So let us start. Wait a minute. So before continue, I want to discuss some term like upchurched, pulse, downchurched, pulse, positive churched, negative churched, red churched, blue churched pulse. Okay. So we know what is GDD, group delay dispersion, that is phi dash dash with respect to omega. So now draw a pulse tree. Okay, so the pulse can be drawn like this. Let me draw the envelope. Pulse can be drawn like this. This is pulse. Of the pulse. This is a normal pulse. Okay. So what happened when there is positive charge or positive group delay dispersion? It increase lambda group velocity or Vg increases. So red has greater lambda and lower frequency. So its Vg is high than blue light. So at this, in terms of time frame, what happened? Red comes prior to blue, or blue comes later in time, then red. So envelope is gonna stay same, but red has come prior to the blue, so red has reached in time. So time here is the in time scale. This is a less time and this is a more time. So red has come before the blue. So red has greater wavelength. So the wavelength is greater here, and blue came later, which has a smaller wavelength. So this happened. So this is called, here the wavelength decreases. So blue comes later. So in greater time, the blue has been drawn. So this is called upchurched pulse, positive chirp pulse, blue chirp pulse. In a good manner. Okay. And opposite of this, GDD is negative with increase in lambda, group velocity decreases. Okay, so red has greater lambda, lower frequency. Here, red will have what happened? Red comes later in time than blue light. So this is time scale. So envelope is gonna same. So here blue comes faster. So this is a scale. On the left hand side, it is a faster time. So on the right hand side, the later time. And this is the blue portion where wavelength is less, and this is the red portion. Okay, this type of pulse is called down chirped pulse, negative chirp pulse, or red chirp pulse. Okay, so if pulse is upchirped, that means red has arrived earlier. Then we need to introduce negative GDD or make red travel longer path. And if the pulse is down chirped, we need to introduce positive GDD or blue needs to travel longer path. Okay, now let's discuss the thing we were discussing the last day. So, compress the pulse chirped pulse amplification. So, what is being done? Basically, the pulse the oscillator produces pulse. Okay, then it is fed into a stretcher. So, so the pulse became stretched its pulse width became delta t in into 10 to the power 5 or 6. Then we amplify it by amplifier. So now pulse width remains same, but its height or peak power increases. Then it is fed into a compressor. So after compressor, what happened? The pulse width came delta t in. Okay, the instruction will be given to you. Basically, it should be MCQ type question, but if it is otherwise or actual instruction will be given to you prior to the exam. Is that okay? Am I audible? So for the exam purpose, I have discussed some numericals. That is enough. And regarding if some numericals, for some numericals, you need some additional parameters. That also I have discussed in those classes. Go through the don't go through that much derivation. Just go through the thing and clear your basics. And what I am discussing and what I was discussing in the last class, they are like, and for some classes, for some class, for in one class I have discussed some atomic LS coupling and JJ coupling. Those are not gonna come. I have discussed only for the better understanding of the thing. So stick to the syllabus what professor have taught in your classes and the assignment questions. And you are also given the uh, question solution paper also. So go through that. And I have discussed in class 3 and also in some other classes coherence type problems. Go through that also. So pulse width become delta t in again. But as when we stretch or compress a pulse, the area of the pulse, or you can say the total energy of the pulse remain same. So here we decrease the pulse width so its height will increase, and that is why sharp pulse amplification being done. And also I have discussed one sum of how to calculate the peak power. uh, just please go through that. If you want, I can discuss that some again today. A very basic discussion. Okay, what will be the peak power if pulse repetition rate, basic questions, if the pulse repetition rate is given and total energy is given. So please go through that also. So what is pulse stretcher or compressor? So they are basically working on the same principle. Okay, which is separation of spectral components and manipulation with their delays. So as I have mentioned already, that if the pulse is upchurched, then we need to introduce negative GTT. Is it is downchurched, we need to introduce positive GTT. Upchurched means red is coming faster than blue. Then if we made that red travels more distance, that then maybe red and blue come together and the pulse is not sharp anymore. Sometimes we need sharpless pulse, so then we need to compensate positive GTD with negative GTD. Sometimes we need sharp pulse, then we need to introduce that positive charged or negative charged. It depends on the application. So for basically, if it is a grating, here light fall in this way, and there is a red light and blue light. Okay, last day I have discussed that what I have discussed that for grating, theta b is less than theta r, so red becomes, okay, for grating is red, that is it is blue, theta b is less, so it diverge less and it is red. And we got this thing here. So if I want to like manipulate the path, I can put a lens here, then this light will go there and this light will go there. Okay, so then even like if the previous arrangement is stretching the pulse, then putting a lens between this, uh, we can make it like compressor. So stretcher, we can make stretcher to compressor by placing only just a lens. Then flip the path of the red and blue components. Let me so normally, sorry. But if you like put a lens here, so you can make blue to go there and red to go there. Then red path will come like this. Here you need to put a lens also. So you can convert stretcher to compressor by only putting this lens, or compressor to stretcher. So what I have discussed, like I'm gonna repeat again, that suppose this is a chart pulse. If you put a pair of grating here and another here, then like this. These are all straight lines, okay? So here, be because of the different orientation. This is red and this is blue. Here the red parts mixed, the blue part, and it will be become chopped, compressed pulse to achieve same effect by the prism. You need 4 prism at least, or you can also use another like grating another pair of grating here, so the pulse and the compressed pulse come in the same line. So here is the prism. Okay, these two side has to be parallel, and just opposite of that mirror image, take the arrangement mirror image. Okay, this is the prism. So this is the sharp pulse. This sharp pulse. So we know that prism arrangement of prism can introduce negative GDD. Here it is, if it is upward pulse, then it can neutralize that. This arrangement can neutralize neutral positive GDD. Okay, then how to do the chopped pulse? Amplification. First oscillator generate pulse, then it fed into stretcher. T in, then it will be delta T in into 10 to the power 5 or 6 times. Then it is fed to amplifier, which will amplify the pulse. Then it will be fed into a compressor. After that, we will get delta T in pulse width again. Okay, so please go through the question I have discussed. I can discuss again uh, how to like gain that how to calculate the average the pulse height with average power and energy per pulse. If average power is of 50 microwatt milliwatt and pulse repeatation with is 80 megahertz. Okay, so energy per pulse, which is actually the area under the pulse, is equal to 50 milliwatt. Okay, it is 500. 500 into 10 to the power minus 3 into 18 plus 10 to the power 6. So by us, it will be about 6.25 nanojoule. This is in nanojoule. Okay. A nanojoule energy pulse is safe for any other component. Okay. So there may be a question why we use grating or prism for stretching and compressing. So when after the amplifier, the pulse power became very high. So the stretcher and compressor are basically prism and grating. Their threshold is much more greater than any other optical component, and they can do the work. So we use stretcher and compressor, and when we do the charge pulse amplification, these things, stretcher, amplifier and compressor, all happen outside the laser cavity, actual laser cavity. So this is energy per pulse. Now peak power, which is P by delta T. Okay. So delta T is pulse width. So where pulse width is 50 femtosecond. So 6.85 nanojoule by 60 into 10 to the power minus 15, really 1.25 into 10 to the power 5 watt. So you can see that if delta T increases, which happen when stretching, peak power decreases. And when delta T decreases, which means compression, peak power increases. Right? Now can see peak intensity. This is called PRR, voice repetition rate. Peak intensity will be peak power by area. Okay. So 1.25 into 10 to the power 5 watt into R square. Here we have assumed so we have stated 4 into 10 to the power 9 watt per meter square. Here also area got it increased peak power. So that means what basically if we focus laser beam same intensity or same peak power smaller area and another time in larger area. The smaller area can get damaged due to in- increased peak intensity. Stay So greetings can handle energy up to 100 millijoule per centimeter square for 200 to 400 picosecond duration pulses without getting damaged. Well, I want to write what I have discussed in letter. Okay, topics like okay, let me open. Uh, see, I'm not going to set the paper. So the professor will going to the set the paper. As much I can suggest you that in some classes there are long derivation. So that's not gonna come in the exam as far as I guess that long derivations thing. But you need to understand the basics of those long derivation and the outcome of that. And yes, like if I mention some topics and then some other thing came, then you will regret and I'll regret also. So I don't want to mention some specific topics. Just go through what I have done in the class. Mm. And like for long derivation, I guess that is no need. But please like build your basics very well. So what's happening? Okay, and another thing, I am drawing red and blue. That doesn't mean there is no other color between this red and blue region. I'm drawing blue part and red part because they are the extreme part of the visible wavelength. All the colors, yellow, green, they are in between those two colors in every diagram. Whenever I have written red and blue, like they are the extreme thing, but other colors are also there. Right? Travel. So what happened here? So the light goes there, it gets stretched, goes back here. Then here is the amplifiers which amplify the light. Then the light comes this compressor and we get this. This is charge pulse amplification. And we use some prisms inside the oscillator for the dispersion as a dispersion compensator. And for the stretcher part and in this amplifier part, we also, sorry, let me write. Used, prisms are used inside the laser cavity or, in the inside the oscillator to compensate dispersion. Then it goes to structure that I have already said. Transducer is basically diffraction grating. Thereof then it goes to, they are not visible in the picture, but I'm telling you the basics. Then it goes to a pulse slicer. that selects only a single mode log files. This is done by epochal cells, polarizing things. Then it goes to amplifier. After and the amplifiers, then exit amplified from amplifier via apocal cell. After the amplifier goes into compressor, which is pair of protein. Okay. Now for very ultra short pulse, for femtosecond chart pulse amplification. So the oscillator is fed by a seed pulse. Okay. So femtosecond, like a pulse which will be 10 to the power 15 second. Second, what are the criteria of the pump failure? First, the wavelength should be close to the absorption maximum of the gain medium. So in the oscillator, there is gain medium. Okay. Second, it has to be a CW laser. Otherwise, sufficient gain cannot be achieved. With nanosecond time limit, so that injected femtosecond pulse in amplifier region gains in energy in multiple rounds. And most importantly, peak power and average power of the pump laser should lie below the damage ratio. Okay, so that's all I want to discuss in the charge pulse amplification. Now, I want to discuss some nonlinear physics. So, as you already know, polarization polarization is chi e. Okay. Chi is linear and non-linear part into E. This is tensor multiplication sign. So chi linear is chi linear only. Okay. But chi non-linear is chi 2E plus chi 3 E square chi 4E and so on. So you can write P as P linear part, P non-linear part. P linear part non-linear into E. This is a non-linear into E. This is P linear part. This is P non-linear part. So for second order, this is epsilon naught chi 2 to E into E. Okay, with tensor notation, it is written as this is the second order nonlinear effect. Right? This is written as chi I j k omega 1 omega 2 e j e k omega 2. What does that mean? That in a second order process, in the medium is omega 1 and omega 2 is fed, we will get a new frequency tau. And the electric field EJ has central frequency omega. omega 1 electric field Ek as central angular frequency omega 2, and we get polarization at omega due to non-linear effect. Remember that all the effects took place in the medium at the same time. Linear effect, second order non-linear effect, third order non-linear effect, and so on. Okay. So, you know, the second order non-linear which is omega plus omega, we get 2 omega. Some frequency generation, which is omega 1 plus omega 2, we get omega 3. Then different frequency generation, which is omega 1 minus omega 2, we get some omega 4 something. Mixing. So this is also called second order. Okay. Parametric up that you get a higher frequency and lower frequency. All these methods will DFG called 3-wave mixing. Okay, because as 3 were taking part in the process. for SFG is called DFG. And another thing, in a non-linear media, okay, what is parametric? Parametric means energy and momentum observed in the process. So this is a type 2. We feed omega 1, we feed omega 2. We do not only get omega 3, we also get omega 1 and omega 2. The intensity will be less, but we'll get that. And another important thing is phase matching. That K3 should be equal to K1 plus K2. Okay. Can be written as omega C and omega. Okay. And I want to discuss some third order nonlinear as as and delta K not equal to 0. Delta K is K minus K1 plus K2 equal sum and difference frequency generation, and it is called 4 with mixing, because what happened here, some frequency generation omega 1 plus omega 2 plus omega 3 lead to omega 4, or here indifference frequency generation like omega 4 minus omega 2 minus omega 1 will get you omega 3. Self modulation. Linear care effect. non-linear Raman and Vilua. This is non-parametric process. Only so in here phase mismatching is delta k4 minus k1 plus k2 plus k3. So the nonlinear polarization equation here will be written as third order nonlinear polarization, written as epsilon naught xijkl. Let's say it is generate omega 4. So it will be generating omega 4, omega 1, omega 2, omega 3, Ej at omega 1, Vk at omega 2, Vl, sorry, Vl at omega 3. Where it is for some frequency generation. Omega 4 is omega 1 plus omega 2 plus omega 3. For difference frequency generation, we need to take in account the conserved electric field. Like, so omega 4 minus omega 3 minus omega 2 will give omega 1. Omega 4 minus omega 1 minus omega 2 will be omega 3. So polarization in this case will be written as like this. Omega 1 is being produced by omega 4 minus omega 3 minus omega 2. into E j omega 4. But omega 3 and omega 2 are minus, so we consider conjugate electric field. Similarly, omega 3 will be shallow naught chi 3 omega 3 omega 4 minus omega 1 minus omega 2 into E j I j k l E j omega 4 E k conjugate omega 1 E l conjugate omega 2. Now I want to discuss cell phase modulation. Okay. So what happened here? You can see that P3 chi 3 E E E. Okay. So let us suppose a material E1 has been fed, E is been fed. If there is E1 is also there, and if we have E2 conjugate also, because let's understand omega 1, omega 2 and omega 3 add up and give you omega 4. At the same time, omega 4, when we subtract omega 1 and omega 2, we'll get omega 3. So E1 and E1 star reside the same time. So here electric field is E1 omega 1 with the central frequency omega 2, E1 star omega 1 plus E2 star omega 2. Okay, this is basically E cube. So first, let us obtain E square. So here E is so we get tons of down to E1, E2, and this complex conjugate term, to E1 star, E2 star, to E1 star, E2, and that's complex conjugate is to E1, E2 star, and another is to E1, E1 star plus 2 E2, E2 star. Okay. Now Pi will be chi I111 to be E1 cube, because it is epsilon not chi I L E1 plus E1 star plus E2 plus E2 star whole square into E1 plus E1 star plus E2 plus E2 star. So we'll get that chi 222 E cube epsilon chi I 112, that will be E1 square into E2. It can be written as epsilon chi 112 I1 E2. Similarly, I221 E1 is there. And also there is epsilon I111 E1 star E1 into E1, and also T22 E2 star E2 to E2. And there will be other terms. I have written only these terms because they introduce third harmonic generation. These two term called cross phase modulation, and these two term called self phase modulation. So cross phase modulation see why it is called cross phase modulation. Because the polarization is modulated by this intensity, which is the intensity of the other electric field. Okay. And also the refractive index, which is n0 plus gamma I. So for cross phase modulation, n at gamma 1 will be modulated by I at gamma 2, and n at gamma 2 will be modulated by I at gamma 1. That is called it is called cross phase modulation. And for self phase modulation, And similarly for E2, and here N and gamma 1 will be modulated by intensity of gamma 1 only. And similarly for gamma 2. Omega 2. So, because of the intensity of other field, if a refractive index of one field is changed, that is cross phase modulation, and if intensity of that field, the refractive index changes, this is called self phase modulation. So here I want to give you the name of the book. Ticks by Boyd, and for other classes go to laser fundamentals, William T. Silverst. So that is for today, and all the best for your upcoming exams. Thank you.